All right, day 2 is a little trickier, but actually, once we get into it, it's really not too bad. They start off looking kind of bad, but with the strategies I'm going to show you, it makes the problem so much easier than it would be if we didn't have this strategy. All right, so what we're talking about today is logarithmic differentiation. And we use this when we have really complicated looking equations. And what you'll see when we go through some examples is if we didn't do what I'm going to show you, you would have to use combination of the product rule, quotient rule several times. And this method really makes it so much easier. And it's only because that we know what the derivative of the natural log is now that we can do this. And so we're going to connect that together with all of our log properties and then make this not so bad. So here are the steps you're going to do, okay? First, you're going to take the natural log of both sides and expand it as much as you can. And here's where I'm talking about. Use your power rule, your product rule, your quotient rule for logarithms, not for derivatives, for logarithms. And when we go through an example, I'll show you what I mean. All right, so after we do that, then you're going to differentiate both sides. And it's going to be implicit differentiation because we're going to have two different variables. And then from there, we just solve for dy dx, and we're done. All right, let's get into these. So here's an example. Really ugly looking thing. And if we were going to use just a quotient rule, for example, or even the product rule, like you're going to have to combine multiple things together in order to do it. It is doable. But there's a much better way to do it. If we take the natural log of both sides, okay, really all we're doing, natural log of this, natural log of all this. What's going to happen here is we're going to be able to use our log properties to split these all up. This is stuff that we did back in Algebra 2. Remember, when we take the natural log of a quotient, you can subtract and separate them into separate logs, subtracting. When you take the natural log of a product, we can separate by addition. So those are those basic log properties I'm talking about, which all of a sudden makes this problem much less complicated. So since I have a product here, I can separate the natural log of this plus the natural log of this, separate them using addition, and then I'm divided by this. I already switched the text to the 1/3, which means I subtract. So now, since we know how to take the derivative of the natural log, this problem just got a heck of a lot easier. We got a couple other moves we can make here, right? Power property says I can take this power and put it in front. We talked about that a little bit with the day 1 lesson. And so I'm just going to go ahead and do that. The 4 comes in front, the 2 comes in front. And now it's a matter of taking the derivative of both sides. And we're differentiating with respect to x. So that's why it looks like this. And so because I only have a y on this side, this is the only part where that implicit differentiation really applies. Since I have x's all over here, it's just going to be straight up differentiation over here. Okay, so this is going to end up giving me just 1/y, but because it's a y and not an x, then I also have to multiply it by dy dx. These I can just differentiate, and then I'm going to have to chain rule here because I've got an inside function. I've got an inside function. This one's not a big deal. And so here's where I'm at. Again, this is the 1/y dy dx. The 4 is just hanging around, so I don't have to worry about it. So it's 1 over this. But then the derivative of this is 3x squared. So that's why it's the 3x squared is on top, because it's this multiplied by 3x squared. Same thing here, 2 times 1 over sine x. But then I have to take the derivative of sine x, which is cosine x. And then this is 1/3 times 1 over x. Okay. On the next slide, I'm going to clean it up a little bit because we have to get the dy dx by itself. And so when I do that, and this is 12x squared. Okay, so this is just me rewriting it. Since this is 1/y, I can just multiply both sides by y to get the dy dx by itself, which is what I've done here. Same thing, and I did change this to cotangent. Just I'm trying to do less writing if I can. If you didn't change it, it's going to be okay. And then what happens is we take what we started with, which is y, and we sub it back in for y here, and then we're done. Unless you can simplify more And in this case, you really can't. I've got a denominator of x to the 1/3. I got denominator here of x cubed plus 1. I'm like, if any of these denominators were close to being the same, or we could get a common denominator, then I would keep going with it. But in this case, that's just not the case. We'll look at one more, again, complicated looking thing when we have power to power and we have variables in the power and in the base. That's where, again, when we take the natural log of both sides, it's going to allow this power to come down. Now, this one is going to end up being a little more complicated than the last one afterwards, but it's still not bad. So when I differentiate both sides, again, I'm differentiating with respect to x, so I'm going to have that same 1 over y dy dx. But when I differentiate this, I have the product rule. And so so again, the 1 over y dy dx, cosine times the derivative of the natural log plus the natural log times the derivative of the cosine. And so I'm going to slide the minus in front. I'm actually going to put the sign in front too. My fear sometimes is that we're thinking we're taking the natural log of this, which we are not. These are multiplied together. And then this just becomes cosine x over x. Again, multiply the y to get the dy dx by itself, so I simplified that. I put the sign and the minus in front. It wouldn't matter. You could put minus natural log sine x, but I mean, we could even, for that matter, we could put the sine x on the x, which makes it more complicated, not less complicated. And then I just need to resub this in for y, and that's it. We're done. Okay. So that's the second part that I wanted to show you for 3.6, and you should have the rest of the time to work.